Hey everybody, we're going to construct an arithmetic sequence in a symmetric sort of way here that makes this, that'll end up making this problem quite a bit easier. Now, I'm going to use some conventional letters here. D will actually be our what we call the common difference. So that would be the first term. The second term would just be R. Okay, when you add D to R minus D, you get R, and then the next term would be R plus D. So you see, these are by construction three consecutive values that differ by D, and again you can check pairwise that each of these differ by D. So we're see at the very beginning of the problem we're trying to find D. In this symmetric way of constructing the sequence really makes the arithmetic substantially easier. So we want to find D here, and also note that R minus D, R, and R plus D are roots of this polynomial. And notice we don't even know what P is, which turns out to be negative product of the roots. But there's enough structure to where we don't even have to know what P is, as it turns out. Now let's see what's going on here. Now, okay, so if this is just a derivation of what they call Vietas, basically. I didn't go through all the work here, but when you expand this out, you get this relationship between the roots and the coefficients here. You can see minus the sum of the roots, or is the coefficient of x squared, and then you have these pairwise product of the roots summed together, that is the coefficient of x, and finally minus the product of the roots is this constant term, which we really don't need, as it turns out. A priori, you might not know that, I didn't, but we don't really need it. Okay, so let's carry on. Now, so really in this context, as far as this expansion right here goes, this would be behaving like your A, R would be your B, and R plus D would be functioning as your C. Okay, and you see already the symmetry is killer here, right? When you add all these up, you get 3R, the D's cancel, and then you divide 3 into 36 and you get R is equal to 12. So we already know the middle term is equal to 12, but we're trying to find the common difference, right? Okay, so, and again, y'all, you see how this happened here? Let me write this down if it's not clear. This minus 36 that I'm underlining is equated with this, because you notice they're both coefficients of x squared here, right? So when you equate them, the minus signs go away, of course, and then everything cancels out, and you get R is equal to 12. Okay, now in a similar fashion here, the 415 you'll notice is the products. I'll underline this. It's a product of the pairs, I guess is a way of saying it. Okay, but that's exactly what this is. This is the products of the pairs, right? This would be what, like R minus D would be, I guess, the C. This would be CB right here, actually, okay? I may not have written them in order, but this would be C. This part would be C right here, and then this part would be B, right? And what would this be? This would be C. Oh, did I get this backwards? No, R minus, this would be the first one, sorry, let me erase. Okay, this would be A, and this would be B, right? Okay, just like we're looking right up here. You don't have to necessarily keep them in order, I tried to though. Okay, and then R minus D again is A, but R plus D is C. So you see, I'm keeping them in this order right here, and so on. Okay, so that's where this came from. Equals to 415. Alrighty. So if you collect like terms, you have R squared twice, right? 3 times, excuse me, and then you just have minus D squared. And again, that's because there's some cancellation going on, folks. Right here, there'll be cancellation of the dr terms from here and from here, and all that's left is minus D squared. Okay, but we have some good news here. We already know what R is, and so we'll be able to solve for D. Okay, so what we get right here is this would be the same thing. 12 squared is what? 144, and 144 times 3 is what? 432. So you would have 432 And again, folks, make sure I did the arithmetic correctly. If r is 12, 12 squared is 144, and 3 times 144 is 420 plus 12, that's 432. Okay, so what you end up with here is 432 minus 415 is equal to d squared. And we find that we actually get two common ratios that satisfy the conditions, but they turn out to lead to the same arithmetic sequence, so it's not really that big a deal. So, and you can verify that, I won't mess with that, but this is 17. This is equal to d squared. Okay, and then we get plus or minus root 17. And yes, you can have two under these circumstances. Perhaps that's because, so this is your answer, folks. The common difference is either plus the square root of 17 or minus the square root of 17. And the reason why you have the slight, if you want to call it ambiguity, is because we didn't even specify p, which is kind of fascinating, you know. P would be equal to negative the product of the roots, and right now you could find p if you wanted to. Again, I'll state p would be equal to minus ABC, right? Just by direct comparison here, okay? And so you could actually find this product here if you wanted to. It's not called for, but it could be another question. The question could be find the value of p. You know, you know what I mean? So you could ask more than one question here. But anyway, the question that we needed to answer was d is equal to plus or minus the square root of 17. Hope you liked it.